because they're really simple. Oh, we didn't start the recording. Okay. There's a Vignere cipher, aristocrat / xenocrypt cipher, affine cipher, Baconian cipher, Hill cipher, and Pollux and Morbit ciphers. So the Caesar cipher is a shift cipher, and it will shift all the letters by a certain number to encode and decode. So it's like when you have two alphabets, like A, B, C, D, E, F, G, H, I, J, K, and then P, so on. And then you shift it all by like one. So it's instead of starting with A, you have the P first, and then and then all your A's become B's, all your B's become C's, all your C's become D's, and D's become E's. So if that's you can just shift the alphabet by a certain number, and that's how you make a Caesar cipher. Bash cipher is the same thing, except you instead of shifting it, you flip the alphabet. So instead of A going to like a certain thing, it just goes to the last letter, and then B will go to Y, and then X, and then so on. So A will go to Z, B to Y, and C to X. So these are the simplest ciphers. Okay, and then this is a Vignere cipher. It's a Caesar cipher, but with a keyword. So then it doesn't have a single shift, and it shifts with a pattern. And then decrypting this would be harder because the key would be harder to find. And then it mostly relies on hints given by the problem to solve if it's a short problem. So how this works is if you have like your Caesar cipher, but then instead of shifting everything by the same, we have a key. For example, if key, I actually don't know. Pretend the keyword is like ABC. And then because A is the first letter of the alphabet, it's 1. B is the second letter, so it's 2, and C is the third letter, so it's 3. So then your first letter, you will shift it by 1. The second letter will shift by 2, and the third letter will shift by 3. And then you repeat the keyword over and over again. And so that's how much times you shift each individual letter. So it's a Caesar cipher with a pattern. And now aristocrat, and xenocrypt ciphers. So in this one, each letter represents another letter, and it's random. It doesn't have to have an order to it. And then the plain text will encrypt into a ciphertext. So plain text is like the one you can read, and ciphertext is the encoded ones. So in a K1 alphabet, the plain text will have a keyword. So it'd just be like a word and then the rest of your plain text, in which this the shift will follow suit with like A, B, C, D, F, G, like. And then in K2, the ciphertext will have a keyword. So this would be alphabet, and then this will have a keyword in it. And then there's also random cipher. So which there's no order to anything. It can map to any letter as long as none of them map to the same letter. So for example, in a K1 alphabet, this could be the cipher. So if you had like a word, for example, like hello, then you can map the H with the cipher to an F, the E to a C, the L to a U, and O to a S. So you get a FCUUS. And then so in K2 you do the same thing, and then random, you can map any letter to any other letter. Uh, so this is an affine cipher. Actually, wait, no. Go back. So what do you mean by you don't understand the big near cipher? Uh, do you know how the Caesar cipher works? So it's like a Caesar cipher, except you shift based on a keyword. So so you have the first letter. I don't know what this is. So you have the first letter, and you shift it based on the keyword, which in this example is key, and which I don't know what letter K is in the alphabet, but whatever number letter the K is in the alphabet, I'm assuming it's going to be like, I'm assuming it's six. It probably is not six. Six is like E or some F or something. But if K was the sixth letter in the alphabet, then you shift this one letter by six. And then, okay, thank you. It's the 11th letter in the alphabet. So you shift this by 11. And then for E, you shift it by like 5. And for Y, you shift it by like 23 or something. Okay, so this is a fine cipher. This is the one you need a calculator for. So it shifts by multiplying the letter by a certain value and then adding another. So just basically you multiply it by A, and then you add B, and you take mod 16. So all letters have like a value assigned to them. So if you get X, like any letter X, you just get the number. Like if it's C, you get 3, and then you multiply it by A and then B. Usually A and B are given, and then you either have to encrypt it or you have to decrypt it. Mod 26 is so you don't go over, because in most situations, if you have like a large not large, a later letter in the alphabet, like for example Z is like 26, 25. Then when you multiply it by a number, it'll get really high, and this will the modulo will, yeah. So mod 26 means the answer has to be lower than 26. So for example, if you have like a 27, it will just go to 1. So you basically subtract as many 26s as you can from the answer. Wait, there are 26 letters in the alphabet, right? I'm not tripping. Yeah, okay, there are. Okay, does everyone understand a fine cipher? Any questions? No? I don't think I explained this one very well. Okay. Next, the Braconian cipher. Okay, never mind, we're going back. So the cipher works as like encrypting a letter, and you multiply it by this A. This value usually is given, and then you add it to the letter, like another number B, which is also usually given, and then you translate it into like another letter. So if you have letter A, right, and then pretend this is your starting letter, so it's 1, and then now this A value is like, pretend it's 5, and this B value is like 3. So then you multiply this A value 5 times your letter, this letter A, and then you add the B value, which is 3. So you get 8. And then whatever you encrypted this A to would just become the 8th letter in the alphabet. I'm not sure what this is exactly. I think it's B, C, H. It's an H. So this will get you an H. And then decrypting is the same thing. So you first do this. This is the mod inverse of A, which you can just have a chart on your, you kind of have to remember this stuff, or you can calculate it out at the end, but it's much faster to remember it. But you just get the mod inverse of the A, which means that the A times this mod inverse, when you mod 26 is equal to 1. So once you do this, you just multiply it and then you subtract, in which you'll just get from H to your A, your letter A. Do you understand now? Because this one is one of the more complicated ones to understand. It's not as straightforward. It's clear. Okay, this is a Baconian cipher, in which you just get groups of characters to solving it. And then the Baconian cipher, the hard part is finding which correlates with what. So to encrypt and decrypt, you break the letters into groups of 5. So you have each letter goes into like this code or this binary. But the thing is, these zeros and ones can be represented any way. So like if you could use fonts to show like zeros and ones. So like if it's an Arial, it'd be 0. If it's like some other font like Comic Sans or something, it'll be a 1. Or it could be any other thing. So the hard part about a Baconian is finding what are zeros and what are ones. And then afterwards, they will give you this chart on your sheet. So on the tests, so you know which ones are A's and which ones are B's. Like you can map like the letter to the code is given to you, but you just need to find which letters. So like if I did like this, and then like I write A's like this, but I write B's in capital, then like one of them could be like 0, and like this one could be 1. So like all capital letters would be 1s, and all lowercase letters would be 0s. And I don't even need to write ABC. I could just write in a lowercase b, and it still would be a 0 because it's a b lowercase, and then the letters don't actually matter, and I could have a capital A. So this would just be 0, 0, 1, 1, 0, 1. And which you would get. I don't have the Baconian memorized. Oh, that is not what I'm saying. You would get oh. They will give you a cheat sheet with the test. So you can't bring your own cheat sheet, but they will give a sheet, like with like okay, yeah. And yes, Morse code is in Codebusters. I need to speed up. So this is a Hill cipher. Is you use no, you do not need to memorize the codes. They will be given. The cheat sheet will be there is like a cheat sheet, but like that's with the test. So like the test will give you like a bunch of values and stuff you need to like so like you don't have to remember everything, but you can't bring your own. It's like you can't like bring what like how to do this and that or like other stuff. But there are basic information on the test provided. Hill ciphers use matrix multiplication to encrypt. So and then this one letters are one less than the alphabetical position, unlike most, which they are just the alphabetical position. So then, in which you have a key matrix of like a 2 or 3 by 3, and you use that key matrix to decrypt. So I won't go into most of the details, but like if your word is like hi or something, and then your matrix is like a 2 and then a 3, 3 and 4. Once you multiply this out, you will get like your word, your encrypted message here. This is harder to do because I can't really explain how matrices work. But if you figure that out, then you'll know how to use it. You just kind of plug everything in. Andrew, do you know a quick way to explain matrices? No, okay. So yeah, the Hill cipher, you just use matrix multiplication, and decrypting is the same. It just you use the keys, but this is harder to find because the keys are really hard to find. But usually they give you the keys and you try to encrypt it. Okay, and here are the Morse code, Pollux and Morbit ciphers. So so there's like Pollux and Morbit. In Pollux, each number represents a dot, dash, or space. So like ones could be a dot. 1, like 2, and 3s are like dots. And then like 4, 5, 6s are like dashes. And then like 7, 8, 9s are like spaces. And these are the same, whatever. And then Morbit, each number represents like 2 Morse characters. No, we're not going to do a Kahoot. I'm just going to give like 1 or 2 practice problems for Codebusters because it'd be really hard to do a Kahoot on this. Morbit ciphers are each numbers are like 2 Morse characters. So in which instead of just being a dot, it might be like a dot and a dash, or like a dash and a dot, or like a dash and a space. And then decrypting, you replace each string of numbers with given Morse character. So like when they give you like your 1, 2, 3, then you replace it with if it's this, you just get it dot dot dot. You get your dot dot dot, in which you just, and then you get, and this is just how you use the Morse. And then if you they will provide the Morse code, so you can just use that, and then you can fill in other numbers by guess and check, because like some things you can't really have 2 X's in a row, and you can't, and sometimes you just won't have like 2, and like some other times like you'll just find a way to like guess and check the other numbers. What do you mean are all the different types of Scioli clubs at the same tryout? There's usually Science Olympiad is with a school. So you're just trying out for the school. And also most schools don't have tryouts. They have multiple teams if you want to join. Oh, events. So you have a team. So you have a team which will allow you to compete. and each team has 15 members. Each member will compete in like 2 to 3 events. And so there are in separate teams. And then how do you get into the events you want? It depends on the team. Usually you just sign up for it. And then like the coach will like decide if you're good enough, then they will just like put you in the team, like the events that you probably want. Most events are interest. I would say having an interest in the thing would really help. How do they see if you're good enough? I guess they don't really. Because like if you have like past experience, they'll probably take you more than like if you don't have any experience. But if you're brand new, just join the team, then they'll probably just give you some other stuff that aren't taken up by other people. Like the previous members, like maybe they specialize in like some events. Maybe you can they probably won't let you take those events. But if they're like just open events, they'll give it to you. And yes, you can bring a cheat sheet to Simple Machines, I think. And then practice problems. I have this from this builder guy. Just a set of practice problem. Also, if you have any other questions, you can ask me while we're doing this. And yeah, you can see what they give you during the test. So there's this, you get this table, and you have the Laconian codes over here. And they also give you some frequencies and the Morse code. So frequencies is like how often like each letter appears in the alphabet.
What if you have already memorized most of Morse code?
Can you repeat your question?
What if you have already memorized most of Morse code?
It doesn't matter. It'll help you because then you don't have to like flip pages, but you could just not memorize it and work off this. But I would recommend just having most of it remembered. Okay, let's find an easy one. Okay, this one doesn't look too hard. I can finish this in 4 minutes. Okay, so we're doing this number 3. You guys have any idea how to start? You guys want to try? If you have like ideas, you can put them in the chat. Yeah, they give the last word is Pam. So this is P. R's, A's, and B's are N. I do not know what Pam stands for, but you probably could figure it out sometime. No. R's, A's.
The RBFGUO could be Amobia.
Amoeba, you mean?
No, it shouldn't be able to because this is the first letter and the last letter are different. So this one can't be.
Excuse me. I just want to confirm.
The last word of Pam is management.
Is the RBGMFBR?
Can you not say it out loud and put it in the chat? This way I can this way no one interrupts each other. Because I am hearing a lot of different people talking. Yeah, I'm assuming this word is amobia. Because it doesn't, no other word fits. I mean, no, the amobia doesn't fit anywhere else. Amoeba, actually, it's amoeba. This is, and you don't get parasitic amoebic management because like the letters don't match. But that's a good guess. I think they should be amoebic though. Actually, no, it doesn't even fit. Never mind. A-M-E-B. O equal P. Long
R
word,
is
I
A.
think. Yeah, R is A. It's given.
So A.
I feel like PAM should be like primary amoebic something that begins with an maybe like meningitis or something.
Primary, that looks right. Oh, it's 5:30. If you guys want, I can send this link to you and you can try it out yourself. But you just basically like do everything right now, and yeah, that's it should be end of class. Okay, I sent the link in the chat. This is question 3. And if you want, there should be an answer key somewhere online. You can just Google it. Bye-bye.
Bye. Thank you.
Bye, thank you.
Bye. Thank
Bye.
you.
Thank you.
Thank